Good morning, everybody, and welcome to Climate Week at the New York Botanical Garden. My name is Jennifer Bernstein, and I'm the CEO and William C. Steer Senior President here at NYBG, and it's a real joy to have you all with us this morning. This year's Climate Week conference is particularly poignant for us here. We have the pioneering Dr. Carlos Nobre making the keynote address in just a moment. I'll have the honor of introducing him and asking him a few questions after his presentation. Afterward, the fourth annual Thomas E. Lovejoy, PhD, and Edward O. Wilson, PhD panel, moderated by our Chief Science Officer, Dr. Mauricio Diaz-Granados, and featuring distinguished guests, will focus on how we can enhance climate resilience through nature-based solutions. We are honored today by the presence of two of Dr. Lovejoy's daughters, Anne and Betsy Lovejoy. Welcome. Today, we are also celebrating NYBG's recently published science strategy that aims to strengthen and amplify our work in plant research and conservation across three cross-cutting initiatives. First, Plants for Climate Resilience centers plants and nature-based solutions in addressing some of today's most pressing environmental needs. This is a theme that you will hear from Dr. Nobre's presentation and in the panel that will follow. We are grateful to the Gordon and Betty Moore Foundation, represented in the audience today by Dr. Avesita Chacon, for their early support in this important work. The second initiative is focused on food and making food plants a global conservation priority. Today, we are thrilled to be launching, with several partners who are in the audience, the Global Conservation Consortium for Food Plants, a major initiative that will bring together botanical gardens and seed banks to strengthen global food security. Our third initiative is unlocking the power of plants and fungi through artificial intelligence, which seeks to harness new technologies to accelerate our work in research and conservation. We are proud to have received early support for this exciting work from the Bezos Earth Fund through their AI Grand Challenge for Climate and Nature. I hope that you'll learn more about our programs and take advantage of being on our beautiful site. You can visit our Science Open House from 12:30 to 3 p.m. You can tour the William and Linda Steer Herbarium, which houses nearly 8 million plant specimens, and the Mertz Library, whose collections contain centuries of botanical knowledge. You can also enjoy our Farmers Market, which will be open from 10 a.m. to 3 p.m. Here at the New York Botanical Garden, we believe in the power and promise of plants, as does our keynote speaker. Dr. Carlos Nobre is a renowned scientist and meteorologist who has dedicated his long and distinguished career to understanding the Amazon rainforest, its role in global climate dynamics, and the impacts of climate change to this crucial region and beyond. Dr. Nobre has helped to establish numerous research institutions in Brazil, including the Brazilian Center for Weather Prediction and Climate Studies, the Center for Earth System Science, and the National Center for Monitoring and Early Warning of Natural Disasters. He was also instrumental in launching and leading the large-scale biosphere-atmosphere experiment in Amazonia, one of the most significant scientific initiatives in the region. He has been scientific director of the Brazilian Research Network for Climate Change, chair of the International Geosphere-Biosphere Program, member of the International Panel on Climate Change, and is a member of the UN Secretary-General Scientific Advisory Board for Global Sustainability, and a member of the prestigious Planetary Guardians, and that is just to name a few of his many affiliations. Dr. Nobre has authored and co-authored more than 250 scientific papers. His research has highlighted the risk of savannization, the transformation of the Amazon rainforest into a savanna due to deforestation and climate change. Currently, he is a senior scientist at the University of Sao Paulo's Institute for Advanced Studies and a leading advocate for Amazonia 4.0, a science-driven initiative promoting a sustainable bioeconomy-based model on the standing forest model. It is my great honor and privilege to welcome him to the New York Botanical Garden. Dr. Nobre.
Good morning to all of you. President Jennifer, thank you very much. And really, it's a great honor. First time I've been here, New York Botanical Garden. This is wonderful, wonderful. One of my ideas when I've seen is really when I go back to São Paulo, I will try to convince São Paulo to have a botanical garden like this one. Rio, as you know, has the Tijuca rainforest there, wonderful, like this one. São Paulo does not. So let's work hard on that as well. But I will talk to you about why Amazon is so close to a tipping point and why we need really looking for nature-based solutions. I will very fast because I have at noontime in New York City, the Planetary Gardens are releasing the Planetary Health Check, the second one, and I have to be there, so I will go very fast. But let me just briefly say, of course, science knows very well the Amazon forest only exists because the forest exists. We have, like all over the Amazon, 6.3 million square kilometers. This 86% is terra firma ecosystem, but also freshwater ecosystem is very important, 14%. And really, the rainforest is very beautiful. This beautiful flora as well, Victoria regia, and very efficient rainfall. I will talk more about that. And if you have ever been to Manaus, you see that the mixing of the Whitewater River with the Black River, forming the Amazon River. Beautiful wetlands as well. Most of the indigenous people, they were, living in this either blackwater wetlands, but also whitewater wetlands. And this is the largest archipelago, fluvial archipelago in the world, Anavilhanas, almost 500 islands. And so the science shows very clearly why the Amazon forest only exists because the forest exists. It's the highest biodiversity, very efficient recycling of water, very efficient recycle of nutrients. The soil is very poor, nutrient poor, but there is a tremendous efficient recycling, very human biome blocks. This is the reason why fires don't spread in the Amazon. Very efficient carbon storage and absorption, and high efficient moisture export beyond the Amazon rivers, what we call the flying rivers. I'll talk more about that. Tens of millions of this evolution store 150 to 200 billion tons of carbon. In the 1990s was removing, as you know, the forest remove all over the world 1/3 of all carbon dioxide emissions that we do. 1/3 is removed by all forests, all biomes in the world. The Amazon was removing up 1 to 2 billion tons, 1990s. And as you know, the largest biodiversity in the planet, you see there, 50,000 plants, 16,000 trees, all those, including the area with the largest number of fish, 3,000 fish in the waters, and also a very important cultural diversity, mostly for 14,000 years, the indigenous people were there, but also new communities, Afro-descendant, riverine communities, also they always lived very well with the Amazon forest. And also, I just want to highlight this ecological evolution. You see the forest recycles water very, very efficient. 1/4 of the trees have deep rooting systems that capture water up to 7, 10, 12 meters. Very efficient recycling, and really 30 to 40% of rainfall in the Amazon depending on this recycling of water. Very, very efficient. And then what happens is that from the trade winds transport the water vapor from the Atlantic Ocean. So there is this very efficient recycling, as I said. Near the Atlantic, 20% of the rainfall depends on the recycling. Near the end is 50% of rainfall depends on the Atlantic. And you see what happens to this water vapor. The end is these 4 or 5 kilometers. So this jet stream comes to the south and really feeds the rainfall systems in the tropical savanna, we call Cerrado, Brazil, Bolivia, but also the Atlantic rainforest south of this tropical savanna. Very important, 50% of rainfall south of the Amazon depends on this transportation. Even in southeastern Brazil, where I live, São Paulo, 15% of rainfall depends on this water recycling coming to the south, and we say flying rivers. Just to give you some figures, coming into the tropical forest, 19 billion tons of water per day, and coming out the flying river, 17 billion tons, just to say how important. If we did not have efficient forest recycling water, we would not have a tropical savanna to the south. And also, a recent study by a former student of mine, professor at Federal University of Santa Catarina, Manini Rota, really shows the importance. That dark green is the indigenous territories in the Brazilian Amazon forest. She calculated how efficient that recycling of water is, and then you see here the rainfall all over these areas, 10 to 30% depends on water recycling indigenous territories. When you put all the Amazon forest, it's much more. But just to show you the importance, also she made a calculation, the recycling of water, the flying rivers, means more than $100 billion a year for agricultural production south of the Amazon. Central Brazil, southern Brazil, just to show you the economic importance of that. But unfortunately, in the 1970s onwards, the military dictatorship in Brazil did not like, I'm in the US, I can say that. Why? Because in the military, I know that much younger people here, but in 1970s, the dictatorship said US would invade the Amazon to take over the Amazon for minerals, iron, gold, cassiterite, etc. Completely non-true. And then they brought hundreds of thousands of Brazilians to get rid of the forest. Livestock, agriculture, mining. So anyway, I'm just saying all these elements, deforestation, degradation, land grabbing, massive fires, selective logging, gold mining, illegal wildlife trade, unofficial roads. So this is the drivers of what is really bringing the land use change. You see here, this is really happening a lot in the Amazon. Deforestation. And the main reason for lowlands in the Amazon, 90% of the first deforestation in the Amazon is for livestock, cattle ranches. There are more than 100 million cattle in the Brazilian Amazon, more than 100 million. So the main driver of deforestation. And you see 1995, southwestern Amazon, you start to see some roads. This is 2022, almost all the forest. This is Bolivia, 1986. You see the roads there, almost all the forest. This is happening. And this is just to see, you can see here, 2000, 2018, the rapid increase in deforestation. We call these areas here arc of deforestation, Atlantic to Bolivia, and then over there, Colombia, Ecuador, and Peru. The Andes Amazon, that's the area with the largest biodiversity in the Amazon, the largest biodiversity in the planet. So these are about 17, 18% of the Amazon forest has been the forest, and this is 22% in the Brazilian Amazon. And the drivers of deforestation, as I mentioned, this is mostly livestock farming there, the main driver, but also in the last decade or so, soybeans. Brazil is the largest soy grain producer in the world. Even now, like Indonesia, palm oil is the main driver, but in Brazil also it's increasing the palm oil. But cattle ranches are the main. And also, of course, not only deforestation that we have about 17, 18% of the Amazon, but we have also a tremendous forest degradation now in Brazil, all those elements. And this very important study by a former student of mine, Davila Pola, show the degradation is timber extraction, also fire, but also the edge effect, border effect, the forest near a larger scale pasture gets degraded, and unfortunately, extreme droughts. The extreme droughts in the Amazon, 4 droughts in 20 years, they are really bringing a tremendous. So we have 34% of the Amazon, several stages of degradation. 17% man-made degradation, the first 3, but also the droughts are increasing the degradation. And, tremendous amount of illegal activities in the Amazon, large-scale deforestation, land grabbing, forest degradation, massive fires, selective logging, roads, gold mining, wildlife trade. The organized crime is very powerful all over the Amazon. Cultural Igarapé Institute calculated this organized crime makes $250 to $300 billion a year. So this is a very big challenge as well. I just want to show massive forest fires as well. Last year, we had a record-breaking number of fires all over the Amazon. We have over 180,000 fires. A lot, we had 240,000 square kilometers degraded by forest fires. And also climate change, heat waves also is making the forest more degraded by fires. Just to give you an idea here, this is for Brazilian Amazon. You see there the degraded area, deforestation reduced, I will show you, 2023, 2024, 2025, but look at the degraded area, 2023, 2024, a record-breaking degraded area, burned areas, you see there, burned areas due to the forest fires. This is a major risk. So basically, just a summary here, I just want to show you a little bit, putting the forest and the pasture here to the side. The forest, as I mentioned, is very, very important in recycling water, very deep rooting systems, and also the forest produces volatile organic compounds, isoprene, for instance. And then there are photochemical reactions of these volatile organic compounds, and then produces a cloud condensation nuclei, very efficient, and then go up, becomes clouds, then strong rainfall. And because of this efficiency in producing clouds, the top level of the clouds is not very high. Because of that, much less lightning strikes. So this is another factor reducing the fires, natural-made fires in the Amazon. And also, most of the solar radiative energy goes to transpiring water, evaporation transpiring, we call evapotranspiration. So the maximum temperature is about 30 degrees on the top of the forest. And very important, element, the tropical forest in the Amazon, is the area with the largest evapotranspiration in the dry season. Look at that, dry season. 4 to 4.5 liters of water per square meter per day. Pasture, much shallower rooting system, becomes maximum temperature 35 degrees, 2 to 3 degrees on average warmer, much less water recycling. During the dry season, only 1.5 liters per square meter per day, 1/3, 1/4. So because of that, there is, I will show some data, 10 to 20% drier in the dry season. So this is, we have close to 1 million square kilometers in the Amazon in either this cattle ranches, pastures, and also soy crops, soy farms. I just want to give you one more data. No, New York Botanical Garden, you also deal very important with the impact on health. So the fire, the microparticles by the burning takes in the Brazilian Amazon 150,000 cases of people, respiratory cardiovascular diseases, tens of thousands of deaths, and also the life expectancy of people over southwestern Amazon, southwestern Brazil, Bolivia, is up to 4 years less because of this pollution. This is one more. So I just want to add now climate change. Just to let you know, of course, no questions about that. Has the climate been suffering human interference? All science shows very clearly the global warming is almost all due to our interference, carbon, greenhouse gases in the atmosphere. But also, I want just to show you what's happening in the Amazon, why we are having record-breaking droughts. We had, because of global warming, the El Nino phenomenon in the equatorial Pacific is becoming stronger. 2023-24, the third strongest El Nino ever, but also a record-breaking warming in the tropical North Atlantic. Those two elements induce air rising there and sinking over the Amazon. That's why we had 2023-2024, a record-breaking drought. Before the global warming, we used to have one drought every 2 decades. Now, 4 droughts, 2005, 2010, 2015, 16, and a record-breaking drought, 2023-24. You see here dolphins. For the first time ever in the Lake Tefé, the temperature reached October 2023, 40 degrees, the water temperature. That led to more than 300 deaths, tens of thousands of fish. So just to show the risks of these climate extremes, including for the biodiversity of the Amazon. And, you know, if we continue with global warming, just to give you one data, to 2021 to 2024, most of the South America will become drier, reduction of rainfall, Central South America, but also the Amazon. So this is the impact of climate change. Let me now tell you the impacts over the Amazon forest of all that's going on. This is a recent study by Luciana Gatti, a colleague of mine, and I'm also co-author of this study. Basically, what we did was to measure carbon dioxide, carbon monoxide in all these 4 sites: southeastern, northeastern, northwestern, southwestern. So this, the deforestation rates you see increased 2010, 2018, increasing all those sites. Precipitation, August, September, October, dry season, reduce all sites, and also temperature increase all sites, but southeastern Amazon. So the blue is the total emissions of carbon dioxide, red is fires, but this is the only place where the forest is a carbon source. Southeastern Amazon, the southern Pará state, the northern Mato Grosso state in Brazil, the forest has become a carbon source. This is really very, very concerning, just to give you here a little bit more. This net biome exchange. So this is really showing that area is very close to a tipping point. I'm just showing that the paper there in Nature is up to 2018. Look at green, 2024. 15 years, 2010, 2024, only 2 years, 2010, 2014, the forest there in that area removed a little bit. Now, maximum becoming a carbon source. The forest there is very, very close to a tipping point. And also, droughts in the Amazon, actually, as I showed you, we are having this record-breaking droughts, and this is 2024. In fact, 60% of Brazil, but most of the South America, we had a record-breaking drought in 2024. And you see here, just to give a few pictures, this record-breaking drought. This is one of the tributaries of the Amazon River, Madeira River, southwestern Amazon. The record-breaking drought you see there, this is the Amazon River. You see there a record-breaking drought. This is the bridge in Manaus, last year showing also this record-breaking. And here you see this is the lowest river level in the Nobre River in Manaus, record-breaking drought last year. Deforestation and fire, as I mentioned, a very dangerous aspect. Last year, record-breaking fire in the forest, 180,000 fires all over the Amazon. And also, of course, this fire smoke really is brought by the flying rivers to the south, brings pollution to the southeastern South America a lot. And also, the fire alters the composition of species, is changing a lot the composition of many, many species. And this is the pollution in South America. You see there carbon monoxide, aerosols, and carbon dioxide. But you know, aerosols and carbon monoxide are very bad for our health as well. And I had just mentioned this study that says more than 150,000 of cases affected by the forest fire, the micropollutants by forest fires in the Brazilian Amazon. Though this is a study, you see 2010, 2019, all those areas in red are very high level cases of diseases, respiratory cardiovascular diseases, and as I said, tens of thousands of deaths. And this recent study is very interesting. You see life expectancy. Look at the southwestern Amazon, Bolivia, Rondônia, 2 to 4 years reduction of life expectancy due to air pollution caused by fires. Just to say one more impact on health. And also another very important, and I had a very good conversation with colleagues here at New York Botanical Garden during breakfast, that also we have to be very concerned, and certainly your New York Botanical Garden, you have beautiful research science on that as well, how changing the biodiversity we affect the health of humans in all respects, so very good research on medicine, but also risks of new epidemics and pandemics. As you know, Ebola HIV was caused by the degradation of equatorial tropical forests in Africa. So studies by two institutes in Brazil, Fiocruz and Evandro Chagas show, I'm just showing here a few, 48 zoonoses. Zoonosis is when a virus can be transmitted by an animal, insect, to humans, becoming epidemics and even pandemics. Listen, in 500 years, for the first time, 2 of these zoonoses become epidemics. Maiaro fever, mostly over the Amazon, and Oropuche fever. Oropuche fever transmitted by insect, affect all over Brazil. It's more than 25,000 cases started last year, just to show a terrible risk, including pandemics. 2 of these 48 zoonoses, these 2, they are transmitted like COVID-19, human to human. One of these, the bottom one here, caused 5 deaths immediately in Bolivia a few years ago. So just to show one more tremendous risk of degrading the Amazon. And also, a recent paper published a few weeks ago showed one more terrible data, that the deforestation also causes heat waves. It's not only global warming, deforestation. And then this study showed 28,000 deaths associated to heat waves due to deforestation all over, mostly, of course, Southeast Asia, tropical Africa, but also more than 2,500 deaths associated with deforestation in South America, mostly in the Amazon. Just to show one more, in addition to risks of epidemics, pandemics, also heat waves. As you know, heat waves is the cause, the global warming, real cause of deaths, assumptions of more than 500,000 deaths a year all over the world. But now this study shows that not only heat waves by global warming, but heat waves due to deforestation. So I want just to show you now the Amazon tipping points. That's the area I'm doing research for a long time. I was the first scientist who published 2 articles, 1990 and 1991, Science Journal of Climate. And that initial article was only if deforestation becomes very large, we are going to have a tipping point. But now, as you know, the science shows we have almost more than 20 tipping points all over the planet, many tipping points, coral reefs, permafrost, ice sheets, Arctic ice, many. And then, of course, Amazon is one that we really are doing research. Jennifer mentioned the largest scale biosphere atmosphere experiment in the Amazon. We started in January 1999, so we have 26 years, and that experiment put a lot of measurements, and that experiment is really showing how close we are to a tipping point. And so the potential tipping points in the Amazon forest, so we really can have a combination of increased temperature, reduction of annual rainfall, dry season length, water depth, and reduction of forest. Just saying, those are the drivers of the tipping point. And studies that we did show, if we really, that's the risks. You have the forest there, and then you're going to have a little bit of forest, but then most of the Amazon will become open canopy, highly degraded ecosystem. It looks like the tropical savanna, but does not have the biodiversity of tropical savanna and does not have the enormous amount of carbon, soil carbon of tropical savannas. And if we cross the tipping point in 30 to 50 years, 50 billion tons of CO2 in the atmosphere, making it impossible to maintain the global warming less than 1.5 degrees. So let me say, these studies show if we had zero global warming exceeding 40% of deforestation, we cross the tipping point. If we had zero deforestation, exceeding 3.54 degrees global warming, we also go beyond the tipping point, but of course we have both. Deforestation, 20-25%, and warming reaching 2 degrees. So as you know, we are very close. Deforestation, 17-18%, and global warming, very close. We maybe 5 to 10 years, we are going to reach 1.5 degrees warming permanently, and if we don't reduce global emissions immediately, we are going to exceed 2 degrees warming by 2050. So the Amazon is really very, very close. And why we say the Amazon is one of the 23 tipping points on the planet, closest to one of those, like coral reefs extinctions, permafrost melting, so Greenland ice sheets melting, all those things. Why? And I'm showing data here. The dry season in the Amazon, 1979, this goes to 2020, but even today, 2024, it's 4 to 5 weeks lengthier. So it was 3 to 4 months dry season in southern Amazon, and always dry season, but the minimum rainfall was 40 millimeters a month. There was rain during the dry season. Now it's 20-30% less rain and 4 to 5 weeks lengthier. So it was 3 to 4 months. Now it's 4 to 5 months. As soon as it reaches 6 months, this is the climate envelope of the tropical savanna. Impossible to maintain the forest. As I mentioned to you, pastures recycle much less water. Soil crops as well. So this is atmospheric water vapor pressure deficit, just so all that area, most southern Amazon, but also in the tropical savanna, much less evapotranspiration, so much drier air. These red areas, tremendous increase in tree mortality, particularly in these areas where the dry season is becoming 4 to 5 weeks lengthier and 2-3 degrees warmer. And this is a study recently published, and it's quite interesting, published a few weeks ago, that show that this area in the southern Amazon, climate change and deforestation transformation, this 20-30% reduction of rainfall in this huge area in southern Amazon, and why the dry season is becoming lengthier. 75%, 3/4 is deforestation. 25% global warming, making these droughts to become much stronger. So basically, what we may say, 30 to 50 years, we are going to it's like that, high level degradation of the forest. Perhaps 30% of the forest will remain near the Andes. Why? Because rainfall is 3 to 5 meters. So even reducing rainfall, there will be sufficient to maintain the forest. So that's what we should expect, 30 to 50 years if we are unable to maintain. Another big risk that we also calculated is that, as you know, when we call wet bulb temperature, when the temperature, the air temperature is 35 degrees, more than our body's temperature, and 100% relative humidity, our body is unable to lose heat. So babies, elderly people, half an hour, 1 hour survival, adults, healthy adults, 2-3 hours. So that's why we cannot anyway let the temperature reach 3-4 degrees by the end of the century. If we reach 3-4 degrees by the end of the century, even here, New York, it will be more than 90 days during summer that will be inhabitable. All tropical areas will be inhabitable at sea level. So this study shows, you see there, that color close to red is when inhabitable. This one, high emissions of CO2. But if we lose the Amazon, the savannization of the Amazon increases tremendously the temperature. So that, let's just say, if we lose if we do the savannization, all the Amazon becomes inhabitable by 2100. Just to give you one more risk of the Amazon. And then, sorry, I only talk about problems, but now I was a scientist, as I mentioned. I've been researching the Amazon for more than 42 years, and I was the first scientist about tipping points. But then by 2019-20, I said, well, I never worked to find solutions. So I decided, and I'm a climate scientist. I'm not an engineer working on finding solutions. And also here, New York Botanical Gardens, you are working very much about a lot of solutions. So, but I said, I at least have to start promoting nature-based solutions. So that's why we are really, I'm also co-chair of the science panel for the Amazon. And we are the science panel for the Amazon Assessment Report 2021 COP26. We are talking a lot about these 4 nature-based solutions: zero deforestation, degradation, and fire; large-scale forest restoration, we call arcs of restoration; creating a social bioeconomy of healthy standing forests and flowing rivers; and of course, valuing indigenous peoples and local communities' knowledge. So now we are advancing the science panel for the Amazon, working a lot. We have produced more than 17 policy briefs released at many COPs, including COP16 biodiversity last year in Colombia. So, but I will show you some of these initiatives. Initially, the zero deforestation, forest degradation, and wildfires. As I said, last year we had a record-breaking wildfires that caused a lot of degradation, and also we don't need to deforest anymore. Most of the Amazon deforest, 62% becomes a cattle ranching. Cattle ranchers abandon a lot, 23%, and 14% is mostly soy crops. And so, a good news in that sense, reducing deforestation, this goes 2023, 2024, we have more than 60% of reduction of deforestation compared to 2022. All Amazonian countries are working hard to reduce deforestation. In the Brazilian Amazon, 90% of deforestation is totally illegal. You see here, that's the Brazilian Amazon, 50% reduction, and then 19% reduction to 2024. And then even 2025, we are seeing a reduction of rainfall, of deforestation. And also, we really have to, very good to be here at New York Botanical Garden, because since we launched this Arcs of Restoration initiative at COP27 Egypt, the Science Panel for the Amazon, really we have to give very large scale to forest restoration. And I just want to say, in addition to forest restoration, as you know, it's Brazil and many countries, all Amazonian countries approved the creation of the Tropical Forest Forever facility. We hope to be launched at COP30. Yesterday, President Lula from Brazil announced Brazil will contribute to $1 billion. So the idea is to protect all tropical forests of the planet, basically to reach a fund, $125 billion, $25 billion from governments, $100 billion from private sector, to have investments, to get interest rates, and to pay $4 per hectare per year of all forests protect 12 million square kilometers of forest all over the planet, tropical forest. So very important, because this is really, unlike the carbon market, this is really to value all the communities protecting the forest. You may think, well, $4 per hectare per year is not a lot, but it will be sufficient to show all ecosystem services, not only carbon, protecting biodiversity for the Amazon, keeping the recycling of water, keeping the flying rivers. All those are very important elements. I just want to say, as I said, they want to get this $125 billion, and we hope they will succeed, and then certainly there will be one more element. The first one, really, to protect the standing forest, not only avoiding deforestation or restoration. The carbon markets make a lot, but this is really very important. And well, just to say, this is what they expect, to get interest rates, and also investments of this $125 billion will be in sustainable future. This social bioeconomy of standing forests, protecting forests, forest restoration, and restoration and remediation. This is absolutely important to protect the Amazon, to save also the waters, to avoid pollution. So this is absolutely important. And as I mentioned, Science Panel for the Amazon, we launched 2022 COP27 Egypt. This is the concept. You're going to see these two arcs of deforestation here, red, and then let's transform a minimum 500,000 square kilometers in forest restoration. That will remove a minimum 600 million tons of CO2. Important to combat the climate emergency, but more important to avoid, as I mentioned, southern Amazon is so close to tipping point. We have to put back the forest there. So the forest will recycle water, reduce the temperature, so it will avoid the tipping point, we hope. And of course, also hoping global warming does not exceed 2 degrees. And this is just to show you, except the southeastern Amazon, most of the Amazon removes 1.8 to 3.6 tons of CO2 per hectare per year, but also secondary forests remove a lot of forests, some recent deforested areas up to 18 tons, highly degraded pasture close to 11 tons of CO2, and also agricultural land 17 tons. So it's very important to do this forest restoration. And then Brazil launched at COP28 the arc of restoration, that area in southern Amazon, to restore 240,000 square kilometers, 60,000 square kilometers by 2030, and an additional 180,000 square kilometers. You see there a total cost of 40 billion, but Brazil is working hard to start, and including donations to all indigenous territories to do the forest restoration. And then coming here and getting to know New York Botanical Garden, I could see a tremendous possibility of partnership between the fantastic research that you do in all respects, particularly forest restoration. Certainly, you know, it will be very good botanical garden to contribute to these forest restoration projects in Brazil. Just to show you, this is the cases of forest restoration in the Brazilian biome, many of those, but still relatively small scale, but very, very important. And of course, there is this big question that you know very well. Natural regeneration costs almost nothing, $500 per hectare, maintains all the biodiversity, but most of the area is so largely deforested in the Amazon that you need reforestation. Natural regeneration does not work. So it's very important really to have partnership with you to give scale. And agroforest systems, certainly they're very important, part of this financial for Brazil's development bank. Also finances for agroforest systems that give a tremendous economic potential as well. So these are all areas with communities creating these agroforest systems. And just to give this native plants, many native plants in the Amazon are tremendous potential, economic, social potential as well. The third one that I mentioned is the social bioeconomy of healthy standing forests and flowing rivers. This is a big challenge. Well, needless to say that, we really have to learn a lot from the indigenous people, local communities' knowledge, to merge that with our science knowledge and create innovative technologies. This is a big challenge, but we have to give scale to that. Just to give you one data, all these Amazon plants, they were domesticated by the indigenous people. So we really have to bring the indigenous knowledge to bear to find the solutions. Just to give you an idea, acai berry is the largest product exported by the Amazon. In the global markets, it's $15 billion a year, but all the value adding, the industrialization is almost more than 95% out of the Amazon. Back to the Amazon is $1 billion. So we really have to bring this capacity of doing value adding to the Amazon. We also made a study, it's ridiculous, all of the Amazon, only we found 171 biofactories of several products from the biodiversity. This is absolutely nothing. Many streets here in New York City have more than 170 factories, one street, all of the Amazon. So we really, just to give you another study that we did, comparing cattle, the livestock, soy crops, with this non-timber forest product, non-timber. There are many cooperatives. Look at that. Profits, maximum cattle, $100 per hectare per year. Workers, 1 to 2. Soy, maximum $300. Mechanized, maximum 1 worker per 100 hectares. Look at this. Up to $700, much more than cattle and soy, and employs 20 to 40 workers. This is the tremendous potential. The people in this cooperative reach middle class, just to show that's really the way we have to do. And just to give you the big challenge, we also did this study. The GDP of all Brazilians, this is Brazilian Amazon, all products of Brazilian biodiversity, acai berry, cocoa, Brazil nuts, etc., 1.2 of GDP. One product, cattle, beef, 17, 15 times more. So we have to change that for sure. This is our big challenge. And so we have all this summary of strategies, the way we have to move towards giving scale to this social bioeconomy of standing forests and flowing rivers. I just want to say very briefly 2 projects that I'm involved. I created this Amazonia 4.0 project, 2021-2022, biodiversity, creativity, and technology. And basically, initially, what we did was to create a laboratory. You can see here, solar energy, circular economy, process of residues, and we capacitated already 3 communities to produce chocolate. And the chocolate from Theobroma grandiflorum, the language in Brazil is cupuaçu. Chocolate from cocoa from cupuaçu, and then these communities now are starting we will make biofactories to produce these 2 types of chocolate, many other products from cocoa and cupuaçu in the Amazon. This is just to give an idea, very high quality chocolate. And also, for the first time now in October, we start capacitating this first indigenous community in Brazil to be capacitated to merge our Industry 4.0 with their knowledge, cocoa to produce chocolate and many other products. And then we already got the donation. We are going to already started building a biofactory. They will produce 250 kilos of chocolate a day. And also, another big challenge I have, I did my undergraduate in Brazil's Aeronautics Institute, ITA, and did my PhD at MIT. So I know the importance of this Institute of Technology, high quality. So we are finalizing a feasibility study to create in the Pan Amazon, all Amazon, the Amazon Institute of Technology, really to be able to create, to protect the Amazon and to create this new social bioeconomy. This Amazon Institute of Technology will have these 5 areas: Amazon waters, sustainable infrastructure, change landscapes, alter landscapes, 2 million square kilometers of forest degraded, how to restore, and then forest and social biodiversity, and also urban Amazon. We hope to launch the concept of this institute at COP30. And then, of course, a larger number, we have already designed a larger number of undergraduate and graduate courses for this Amazon Institute of Technology. And as I said, Pan-Amazonia. In many countries, we are finishing now designing 6 innovation hubs in 4 countries: Brazil, Colombia, Peru, and Bolivia. And last but not least, indigenous people, local communities knowledge. Well, a big challenge, but we have to find solutions, how to really merge our science knowledge with the knowledge of indigenous people, Afro-descendant, riverine communities. And we really have to pay attention. You see here in these indigenous territories, this color, they are 25% of the Amazon. They maintain most of the Amazon. Globally, as you know, indigenous territories maintain 80% of the global biodiversity. So really, we have to go in that direction. And as I mentioned, the indigenous people came to the Amazon 14,000 years ago. 11,000 years they were in most of the Amazon. And they developed indigenous science. They use more than 2,300 products, almost 1,500 medicinal plants, oils, 250 edible fruits. So this is really just to show how important it is for us to merge with the indigenous knowledge. And this is also a paper published a few days ago showing that Amazonian fruits are very important for our health, not only as a food, but also many chemical products improve tremendously our health. The indigenous people knew that for thousands and thousands of years. We had this really very important indigenous leader, Chai Surui, from this Paiter Surui indigenous community. She was at the opening of COP26. If you were there, you may remember she made a beautiful speech. And also, you remember, in June 2023, this aircraft crashed, died all grown-ups. 4 children survived. These 4 children, Leslie, 13-year-old, Solani, 9, Tien Oriel, 4, and a baby, 1-year-old. These 4 children survived 40 days in the Amazon, 40 days in the forest. And the president of Colombia, Petro, said it was the wisdom of indigenous families living in the jungle that saved these children, just to show the importance of indigenous knowledge. Final considerations, let me finish by just saying, looking ahead, really, we want really to create the conditions for this new bioeconomy. We need also a larger scale financing for avoiding the tipping point of the Amazon. As I said, we may need something like more than $150 billion to do the forest restoration of large part of the Amazon. So let's create the environmental power of this social biodiversity. And our vision is that Amazonian vision for the present and future We have to protect 70, ideally even 80. The indigenous associations, COICA, in the Amazon, they always say 80%. They used to say by 2025, but unfortunately, still we have deforestation. So now by 2030, to go to protect and to start restoring that large area, maximum 15, 20% agroforest system. This is forest, but for the social bioeconomy, this is 1 million square kilometers, sufficient to produce products from all Amazonian countries, but from all over the world. Maximum 10% regenerative agriculture, livestock, mining, etc. So this is our vision for the present, for the future. So the living and sustainable vision for Amazonia. So this is really the knowledge of the Amazonian nature based on science, technology, innovations, and the knowledge of indigenous people, local communities as the path to sustainable socio-economic development, environmental conservation, with a bioeconomy of healthy standing forests and flowing rivers. So this is my final message to you, and I just want to finish. Again, thank you very much for being here. I'm very emotional to be here in this beautiful New York Botanical Garden. And then, please, all of us, let's save the Amazon. Let's save the Amazon people. This is the Amazon all of us want. Thank you.
Thank you so much, Dr. Nobre, and I know that you're headed off to your next Climate Week event, such is the way with Climate Week. Your comments were, on the one hand, sobering, a reminder to all of us of the critical role that we each need to play in addressing the climate and biodiversity crisis, but also put forth the important role that nature-based solutions and biodiversity-driven solutions can offer to us as we make progress towards the goals that you laid out. So thank you so much. There is going to be a 15-minute break, and we're going to have our panel beginning at 10:45. So we'll see you all in a few minutes.